In the last video, we saw that there are some compounds that have names that contain Roman numerals. Generally, these are compounds that have transition metals or poor metals within them. Examples from last time were iron 2 oxide and iron 3 oxide. Roman numeral 2 in iron 2 oxide indicates that the iron is in the +2 oxidation state. In other words, it has a positive 2 charge. The Roman numeral 3 in iron 3 oxide indicates that the iron is in the +3 oxidation state. Knowing what the charges on the positive ions are, and the fact that oxygen will always have a -2 oxidation state, you were able to write the formulas for the compounds as FeO and Fe2O3. So, if you know the name of the compound with the Roman numeral, you know how to figure out what the compound's formula is. But if you were given the formula, could you write the name of the compound and get the right Roman numeral in there? Let's start with one that you would already know how to name, MgO. Now the Mg is magnesium, the O is oxygen. We already know that the oxygen would have a -2 charge from the periodic table, but without a table, could we say what the charge on the magnesium ion would be? Well, it would have to be +2, because that's the only way that the compound can be charge neutral, and that is that there has to be a balance between the positive and negative charges, the same number of each. So, we could call this compound magnesium 2 oxide, the Roman numeral 2 telling us that there was a +2 charge on the magnesium. But we're not going to do that because magnesium always has a +2 charge. So there's really no ambiguity, and when there's no ambiguity, we don't use a Roman numeral. A quick check on the periodic table shows us that magnesium does in fact have a +2 charge. Now how about naming FeO? Now iron is a transition metal, so we now have to go and look at that table of transition metals and their oxidation states, and we see that iron has two possible oxidation states, +2 and +3. The question is, which one do we have to use? Well, we're going to have to calculate it. So back to FeO. We know that the oxygen is going to have a -2 oxidation state, but again the question is, what's the oxidation state of the iron? Well, we look at the formula and we see that there's only one iron involved here. We also know that the charges have to be balanced to make the compound stable. So what does the charge have to be? Well, it has to be +2. So we're going to call this compound iron 2 oxide. Let's take a look at the other iron compound, Fe2O3. Now again, the oxygen is going to have a -2 charge. So we again have to answer the question, what's the charge on the iron? Now this time, there are 2 iron atoms in the compound, and there are 3 oxygen atoms. Now, we know because of the 3 oxygen atoms and the fact that they have a -2 charge each, the total negative charge in this compound is -6. Now we have to make sure that all the positives add to +6. Well, we have 2 iron atoms. What charge do we have to multiply the 2 by in order to get to +6? It has to be +3. So that means that we're going to have an iron 3 ion, a +3 charge. So the name of our compound is going to be iron 3 oxide. Let's try 2 compounds that contain copper and chlorine, CuCl2 and CuCl3. Checking the periodic table will tell us that chlorine always has a -1 charge. Now, in the first compound, there are 2 chlorines, so taking those 2 chlorines multiplied by the -1 charge gives us a total of -2. Now, there's only 1 copper, so how much charge does that 1 copper atom have to have in order to get a +2 charge? The answer, of course, is positive 2. So we're talking about a copper plus 2 ion, which means that we'll call this compound copper 2 chloride. For CuCl3, we have 3 chlorines, each of which has a -1 charge, so we have a total of -3 charge. The 1 copper ion has to also produce a positive 3 charge. What would be the charge on that ion? Well, positive 3. So we have a plus 3 copper ion. So we'll call this compound copper 3 chloride. Go back over this video as needed, but most of all, practice.